right. We are here in chapter 9, the last chapter in stats. So chapter 9 is all about what we call sampling, sample means or samplings of means. And we're going to talk about its distribution, and we're going to get a new kind of test statistic that we can deal with. So it's kind of going to be like chapter 8 all over again, but styled just a little bit differently. So the first thing we got to talk about in 9.1 is we're going to talk about sampling means of random samples, or sorry, sample means of random samples. So we're going to be talking about more than one mean in this. So it's not just doing a random sample and getting the mean and stopping. We want to do multiple random samples and get the means and work with all of the means. Okay? So, couple things in this. You're going to review, again, things that we already know. So this was back in, I think this fell into us in chapter 7. Yeah, 7.1, I think, when we talked about how populations and parameters are unknown and sample and statistics are known to us. Okay, and then we have these lovely symbols again that you've seen before. This is mu, which represents the population mean, sigma, which is the population standard deviation, variance, which is sigma squared, and population proportion p. And then on the statistic side, you have the sample mean, you have the sample standard deviation, which is S, and that's X bar. So we're going to be talking a lot about X bar and actually multiple X bars because it's sample means. Okay. And we've got sample variance, which is S squared. And finally, you got P hat, which is the sample proportion. Okay. All right. So a couple other things that are going to continue to follow you here in this first section is that you're going to go back to the normal distribution curve, and we're going to do a little bit of the empirical rule coming right out the gate in here. And you're going to see how these are going to really relate to what we're talking about. All right. So let's talk about sample mean and standard error. So X bar, and actually this should be sample means, to be more specific. Sample means and standard error. Okay. So sample means, talking about that X bar. On average, the sample mean is really the same as the population mean. Okay. On average, which means that we need to have multiple means that we average out. So if we ran a sample random sample experiment or random sample, multiple times, and we took all those means and averaged them. So it's like you're getting a mean of all the sample means. Okay. It's going to be the same as the population. It should, on average, be the same as the population. And with that being said, we like that because this means, not that kind of mean, but this means, as in meaning, it is an unbiased estimator, which is great for us because we like to work with things that are unbiased. Okay? We like to work with things that are unbiased because that increases the accuracy. Okay? On the other side of this as well, so knowing that the sample mean is the same as the population, again, on average, because you're looking at more than one, the precision of the sample mean depends upon the population distribution. So the standard error is what we're talking about with the precision. So the standard error gets more precise, or in other words, will decrease. The smaller the standard error, the more precise you are, okay? And so that means that the standard error decreases when we increase the amount of observations or the sample size. So we can make our samples more precise by increasing the sample size. So as we increase that sample size, the standard error decreases, which makes it more precise, okay? Which helps with the precision overall. And these are two things that we like because we want to be unbiased and we want to be precise. If you remember back in chapter 7 when we talked about that, okay? We like to be unbiased and precise. Now, a couple other things. So standard error is going to be found by taking sigma divided by the sample size that is square rooted. Okay. So sigma divided by the square root of the sample size. That's how you're going to find your standard error. Okay. Another thing is, again, we're talking about taking multiple samples and having multiple means. Okay. So when you take those multiple samples of means and you display them in a distribution like a histogram, we call that sampling distributions of the sample mean because we took a sampling of all the sample means. So again, this is just a definition. So when you see something talking about a sampling distribution, we're talking about all those sample means, okay? So again, a distribution of all possible sample means that would result from drawing repeated samples of a certain size, and that should have an E in it. I'm all over the place today in here. Certain size N from the population, okay? So whenever you hear me say sampling distributions, I'm talking about a sampling distribution of the mean. And with that being said, again, when we talk about these sampling distributions, this is true for them. That on average, the sample mean is the same as the population. And the precision will increase or, well, really depends upon the population distribution. Or in other words, the standard error decreases with the increase in the sample size. So right here you can see why it's dependent. So this is from the population distribution, hence the precision is dependent upon that. And then right here, the larger we make this, okay, the smaller it's going to make the whole division of this come out. Trust me on that. All right. So that's really what 9.1 is all about. I mean, just kind of getting these two pieces out to you. The big thing is that the sample mean is the same as the population on average, and we call that an unbiased estimator. Sometimes the book will like to, or not the book, but your assignment likes to say that, let me get a good example of this. It says that the sample mean is an unbiased estimator of the population mean. So there you go. You know, that's how they kind of say it. All right. So, and again, when you're talking about precision right in here, this is all about the spread of the data. Okay. So it's talking about the spread of the data. So as we increase the sample size, the spread gets smaller. All right. Okay. So let's talk about what you're going to see in your assignment. Again, a lot of this is just review. There's not a lot of new stuff here. So go ahead, let's talk through this one because I have an example right below it. So it tells you that there is a study of all students at a small college showed, or a study of all students at a small college showed a mean age of 20.7 and a standard deviation of 2.5 years. So the question is, are these numbers statistics or parameters? Tell me why. And then label both numbers with their appropriate symbol. Is it X bar, mu, S, or sigma? And so since we're talking about this, the big key word in here is the word all. When you're talking about everybody, remember back when we talked about population, all is a signal that you're talking about everybody. So you're talking about the population here. Okay? So that means that these numbers are parameters. Okay? Because you're talking about everybody. So since they said this is the mean, that means the 20.7 is mu. Since this is the standard deviation, that means the 2.5 is sigma. And there you go. That's what one of your problems is going to be like. So go ahead, pause the video, give this one a shot, and go. Okay, so in this one, hopefully you saw that this is a survey of just 100 students. Hopefully, this says a large university. A large university definitely does not consist of only 100 students. So this is not everybody at that university. So that means what you're dealing with here is a statistic. So with that being said, then up here, it says the mean number of semester units that students were enrolled in is 15.2. So that represents X bar. And standard deviation of 1.5 units, that represents S. So hopefully you got that and you're all good. So let's move on. Again, like I said, most of this is review. So this is kind of review of what we did back in chapter 6. Okay, there's that normal distribution that they're talking about. They want you to sketch a curve and then, find the probability that we will be bigger than 80% or bigger than 80. Okay, go ahead, pause the video, and do this. You've done this before. This is just like what we did in chapter 6, exactly the same. Okay, so the first thing is sketch the curve. So you've got this normal distribution. Wow, that's horrible. Let's redo this. Oops. Let's get it so it can actually draw. Okay. In the middle goes mu, because that's what this is. Okay. So this is our mu. This is our sigma. So in the middle goes a score of 70. And then when we go out to 1 standard deviation away, our standard deviation was 10, so that means this is 80. When we go out to 2 sigma, that's 90. And then when we go out to 3 sigma, that's 100. Okay, then we go on the other side. Here's -1 sigma, so that's 60. Here is -2 sigma, which is 50. Here is our -3 sigma, which is 40. So that's really the picture that they're looking for. Okay. In part B, they'll actually have you sketch a curve of this shade the curve. They're going to be looking for that. So they're actually looking for, what is this probability that's all up here? Okay. Well, if you remember, we did all this math, and this was 34%. Actually, let's change up the color. This was 34%. 34%. Out here, these two pieces were 13.5%. 13.5%. Let me just double check my math on that, because sometimes I forget. Yep, 13.5. And then from there, this was 2.35%. And in previous videos, we found this guy to be 0.15%, just so you know. And again, same thing that happens down here. This is your 2.35%. This was your 0.15%. We figured all those out. So if you want to know what the probability, okay, is going to be, just take and add these three up. Okay. You could also go into your calculator if you really wanted to do this, because you can go into your calculator or into StatCrunch and calculate the normal, where you put 70 in as your mu, 10 in as the standard deviation. You're going to hit the greater than sign, because what you're looking for in this is the probability that we are greater than or equal to 80. So you'll put in the greater than sign, you'll put in the 80, and then you hit calculate, and it pops up right here what the answer is. So if you take 13.5 plus 2.35 plus 0.15, you get 16%. And that's what they're looking for in Part B. So Part A is all the stuff in green. Part B is the blue and the purple. Okay? Just like what we did before. Nothing new. Okay? So now this is where we kind of start talking about some of that new stuff. So right here it says a human resource manager for a large company takes a random sample of 50 employees from the company database. She calculates the mean time they have been employed. She records this value and then repeats the process. She takes another random sample of 50 names and calculates the mean employment time. After she has done this 1,000 times, which she's got a lot of time on her hand if she does that, especially if she's doing it by hand, she makes a histogram of the mean employment times. Is the histogram a display of the population distribution, the distribution of a sample, or the sampling distribution of means? Pause the video. Tell me which one it is. Okay. So hopefully you said sampling distribution of means, because she's taking all of these means and she made a histogram out of them. Okay? Because if she didn't, I mean, if she went through all this work just to find the mean once and ignore the rest of the work she did 1,000 times, that's just silly. Okay? And this doesn't represent the population, because she's not taking everybody, she's not finding everybody's times and calculating the mean. So it's not that. And it's not a distribution of a sample, because she's doing this for more than one sample. Okay? She does this 1,000 times. Okay? So this is that sampling distribution of sample means I was talking about. Okay? All right. And last but not least, you'll see one like this. Go ahead and pause the video. Give this one a shot. Okay. So in this one, it says the average income in the District of Columbia in 2013 was $76,000 per person per year. And that was larger than the average for any state. Suppose the standard deviation is $35,000 and the distribution is right skewed. Suppose we take a random sample of 100 residents of DC. Okay? What value should we expect for the sample mean? Okay? And why? And then in part B is, what is the standard error for this sample mean? Okay? So in this, for part A, let me write this up. So part A, hopefully you said that the expected sample mean, $76,000. Okay? Hopefully you said that that is the expected. Okay? Reason why we can do that is because the sample mean is an unbiased estimator of the population mean. Okay? So since the population mean was this, we expect the sample mean to be around that. Okay? And again, we would have to do lots of sample means in order to see this really fall out. But we expect all of our sample means to be around this number. Okay? All right. So there's part A. And again, it's because the sample mean is an unbiased estimator of the population mean. Okay? Part B says, what is the standard error for the sample mean? Well, again, that's just a formula. Remember the formula I gave you? Sample or standard error is equal to sigma divided by the square root of n. So again, just kind of labeling some things up here. I should have labeled this before. There was your mu, because this is about the population. Here is the sigma. Okay. And then down here, this is your sample size. So if we take 35,000 divided by the square root of 100. And if you go to your calculator and figure this out, it's really 35,000 divided by 10, which gives you $3,500. Okay? If we increase this sample size, what will happen to my standard error? That's right. This should go down. Okay? The bigger the sample, the lower this number will go. Also, just so you know, when it comes to the spread of the data, your sample distribution information, your sampling, its spread will be smaller than the population distribution, just so you know. The sample spread will be smaller than the population distribution. Okay? All right. So with that being said, here are the questions in the chapter 9 homework for 9.1. Have fun.